manufacturing sector of manufacturing, and our solutions kind of follow this wheel here: create, simulate, manage, publish, sustain, and build. And we have an IT solution, either software or hardware, for each of these categories. Today's presentation, we're going to focus in on the create function. And we're going to focus in on how you can use the SOLIDWORKS application programming interface to get a little bit more mileage, a little bit more leverage out of your SOLIDWORKS investment, and obtain a better return on investment from that initial purchase of SOLIDWORKS that you all made or you're contemplating on making in the near future. So with that, why don't we start with just a simple definition: the SOLIDWORKS API, as we call it, and automation in general. And as you can see on the slide here, the API in SOLIDWORKS is a toolkit that provides a programming interface so that you can automate or manipulate commands within one of the SOLIDWORKS applications. The SOLIDWORKS core application, but some of the other SOLIDWORKS products also have an API toolkit that you can leverage. The EPDM application, for example, has a toolkit, and it allows you to automate it. And the reason to do that, the purpose of leveraging the API, is to achieve some design automation. In other words, automate some functions that normally would be done in 3D by one of your engineers or designers. It's also used to provide some customization so that you can get some very specific results out of your SOLIDWORKS investment. And finally, it allows you to interface from SOLIDWORKS to another system, maybe at the front end with a CRM system, or maybe on the back end with valuable bill of material information that you're seamlessly linking into your ERP system. So that's the definition or the very fundamental view of the SOLIDWORKS API. And as it relates to design automation, I like to present our view of design automation, and I see it being in three levels of capability. So the first level of capability for design automation within SOLIDWORKS is a very fundamental, straightforward capability named configurations. And configurations in SOLIDWORKS is a standard feature. It comes with every package from Core on through Premium. And it's a feature within SOLIDWORKS that leverages Excel so that you can drive variations in a part or in an assembly. And it allows for the coexistence of multiple definitions of a design to exist within one model, but the user would only be seeing one version at a time. And it's a very powerful tool. Many of you probably are already using configurations, and it's the very fundamental level of design automation within SOLIDWORKS. The next level of design automation that you can attain is what we would refer to as customizations with the API toolkit. And at the very fundamental level, the API toolkit provides you with a macro recorder in SOLIDWORKS. So when you turn it on and record, you can go ahead and model something, capture those menu clicks, and then replay it so that you can repeat that function very quickly. Many of you probably have several macros that you've developed and that you use, and that would be the fundamental capability within SOLIDWORKS API toolkit that you'll see today in the demonstration. But on another level, you can leverage the toolkit so that you can write your own code, write it in VBA or VB.NET, and automate almost any of the SOLIDWORKS features and functions. The toolkit within the SOLIDWORKS program is very powerful, very rich, and one of the best API toolkits in the industry. And then, as I mentioned, you can utilize that toolkit so that you can integrate or share data between your SOLIDWORKS environment and another outside system, such as an ERP system or a PLM system. The next or final level of design automation I'd like to present is what we refer to as a generative KDE, knowledge-based engineering solution. And this would be automation that you would implement with very, very complex rule sets, providing an extensive amount of capability. Generally, it relies on an external rules engine and an external database to store all of the design attributes, variables, and results from an iteration of the KDE tool. And it almost always is accompanied by some custom API programming that will automate the geometric functions and link them to the rules engine. So some examples of the engines that are out there and available would be Configure 1, DriveWorks, Tacton, 3 examples of KDE solutions that are available to be integrated with SolidWorks. So today's presentation is going to focus right here in the middle. We're going to talk about the API toolkit and show you some really good examples of what can be done with it.
Again, my name is Steve Fick. I'm the Applications Engineering Manager with Fisher Unitech, and we're just going to hit on about 4 or 5 examples today that leverage the API in some pretty unique ways. And so the first thing is that I thought we would just touch on, as Charlie mentioned, the creation of a macro. This is one of the most fundamental ways that you can begin to leverage the API. And as you start to dive into the API, there's really three main sets of automation or customization you can focus on. One is macros. These are going to be very, to a large degree, static in the sense that I'm going to either ask the user for information or in a form and then just push it into SolidWorks. Or I may not ask them for any information, and I may just want to run a series of commands. You know, it's a very set amount of information that just needs to happen when I run it. Alternatively, you can create what are called add-ins. And an add-in in SolidWorks is a little more dynamic in its nature, meaning that the add-in can actually listen for events. So one of the most common things you might think of is the fact that I want to do a rebuild. And on a rebuild, that's an event in SolidWorks. And when the rebuild happens, I may want to recalculate whatever my automation is. Okay? The third type is an external API, and that's one that would stand on its own and come out and leverage SolidWorks and manipulate some things and then complete. So those are I'm actually going to show you 3 examples, or show you some examples that touch on those 3 areas. And initially, let's start by just creating a macro. SolidWorks again comes with a macro recorder. A lot of people aren't aware of this, but it's really nice. You bring up the macro toolbar. I can say, you know what, record. And what it's going to do is it's just going to start recording each of the steps I make. So we won't get too fancy here, but the idea is that basically I can, put some geometry on the screen. Let's just extrude it out a certain distance. And again, as I'm making each of these clicks and I'm doing each of these things, starting new sketches, creating cuts. Let's just put a hole through the middle here. And set it to through all, and then we'll add a few chamfers to the edge of this block as well. And all along the way, as I'm doing each of these steps, the macro recorder is actually just recording them in the background. And when I'm done with the series of steps that I wanted to create, I just hit stop. So it's a lot like an AVI, if you will. And when I hit stop, it just asks me to save it out. And now I have a macro that I can leverage. If this is a type of geometry that I create a lot, I can just simply play the macro. What's really neat about SolidWorks is the fact that I can actually assign that macro to a hotkey.
Webinar, a training thing, yeah.
So if you imagine starting a part from scratch and then just coming up and hitting play and selecting the macro I want to run, what you'll see is it just goes off, creates the block, puts the cut in, and puts the chamfers on the block. So it's just a way for a set of repeatable commands that I do on a daily basis. I can record them and then leverage them going forward. Either from a hotkey, or I can actually create a it's pretty easy to create a toolbar icon as well. So again, pretty static in nature. I'm just sending some commands into SolidWorks and saying, hey, do this. So we kind of have a foundation to build off of. I'm going to show you another really exciting example that we've begun to develop, and that's something that's actually leveraging Google. I think all of us probably in some way or the other have had some interaction with Google. Google has a pretty unique capability that they have an API as well. And you can start to do some pretty exciting things when you combine Google with SolidWorks. And so one of the first things that we can, in this example, is, this is a really neat looking part, but if you look over in the feature tree, it's in Chinese. Okay, and this is becoming more and more of a reality for many of us, is that we're getting parts that were, developed in another version of SolidWorks. We have to make edits to them to be sure it's not. Most of us probably aren't extremely fluent in Chinese. I'm not fluent at all, but it can be a challenge to try and manage the feature tree in this sense. And so one of the really exciting macros that we have begun to play with is actually leveraging Google Translate to manipulate the feature tree to a different language. And so this one's, again, this is pretty cool. I'll actually bring up the code just to show a little bit of this as we go through it. But let me just browse to where that is. And again, Google is becoming one of those tools that we're looking at more and more opportunities to integrate it into the different APIs. So you begin to think about the fact that eDrawings and Enterprise PDM and simulation and 3D VIA, they all have API toolkits that you can begin to manipulate and to leverage. And so this is the code related to this, and really what I want to just point out is that it's pretty simple. We're basically just passing some information related to the Google API. In this case, as you can see here, this represents a language of the existing feature tree. In this case, it's Chinese. And then I can manipulate and say, hey, my target language in this case is English. And what happens then is that when I go ahead and run the macro, if you just watch over to the left, it's going to go out and begin to translate the feature tree into its English counterpart, which is really just exciting. The stuff that you can do with Google and some of the other toolkits that are out there is pretty amazing. And so now I've got a feature tree that's in English. My designer can actually understand what the feature is, not have to hunt and peck around quite as much. But again, just an opportunity where a macro is a great fit because it's just needing to pass some information to the part file without a whole lot of user interaction needed.
Feature name equals
translate. So again, that's another great macro feature that that we've begun to develop and leverage with some of our customers. So those are macros. Another subset of the API is add-ins, and again, an add-in is something that is geared more towards needing to be dynamic in its nature. Okay, and so this is an example that I'll bring up that again Charlie had shared that Whiting was kind enough to let us show. And this was kind of an interesting case because sometimes the API is not always so much about automating as it is customizing the way SolidWorks operates. Most of us are familiar with the fact that SolidWorks does a really nice job of hitting, let's just say, 75% of the way people do things from a process standpoint, and is able to adapt very well to those situations. But there's always going to be those cases where sometimes it's easier to adapt SolidWorks to the process as opposed to adapting the process to SolidWorks. Sometimes the cut list is a good example, and so one of the things that this does is the requirements were that, hey, we want to be able to have the weldment file name. We want it to be able to dynamically generate part numbers for the weldments based on a set of rules. It says take the file name and take a call out that Whiting uses for their weld members and begin to generate part numbers for these different weldment items. And what you'll notice is this was created as an add-in, and part of the reason it needed to be an add-in is because you'll notice that we actually have a feature in the feature tree. And with an add-in, this now becomes dynamic, meaning it can recalculate the cut list information upon a rebuild or upon a change. So it's listening into SolidWorks and saying, hey, on this event, you need to make sure that you're updating and creating accurate information. And just to draw, again, the comparison, a macro would have to be physically reran, right? The user would have to initiate the macro. So what this actually does then is that these are grouped in subsets. So Whiting basically categorizes their weldment members together, and then has the ability to run the cut list add-in. And it's just a menu item. Again, this is kind of another nice aspect of the add-in, is it can be really integrated within the SolidWorks environment. And it helps to aid in the user's creation of the cut list. It's, again, taking the part number, supplementing it with a mark that's designated for certain structural members, and creating the part number, pulling in the quantities, specific materials that are associated with those, and then the description for it. And again, this is a situation where it's nice because it's allowing the designer not to have to physically manipulate the cut list in order to achieve the end goal, okay, to meet the end manufacturing goals. The other nice thing about this, and again why it really needed to be an add-in from an API standpoint, is it's editable. So there are situations that the ability to change a quantity without the need to actually physically model more of the component is oftentimes a requirement. And so, for instance, the user has the ability now just to double click on this, adjust the quantity, and apply it. And when it's applied, what you'll notice is that the override then shows up down here for that line item. And what's really key about this is that because it's been overridden, it now has, we have to be able to indicate to users when they view the cut list that it is in fact overridden. And again, we have the ability then to fire up the cut list master again, and anyone who opens this file now can see items in red that have been overridden. So there's a couple areas that users are allowed to overwrite, and it's dynamic, and this provides them feedback that has in fact been overridden. Okay, so this is a little bit of automation, but more of customizing SolidWorks to meet a specific requirement. And that's, again, one of the beauties of SolidWorks, is it really becomes the foundation for being able to make adaptations to SolidWorks itself. So again, that's an add-in. Appreciate Whiting allowing us to talk a little bit about that. Another add-in, and this is an API example that we've gotten a lot of traction with over the years, and that's related to, I want to be able to take a set of coordinates, push them into SolidWorks, and create a tube. And it sounds simple, but it's a requirement that we've had over the years, and so we've created an add-in that basically has kind of morphed and merged itself specific to customer requirements. But the nice thing about this is that it provides, again, an interface that the user can input data in a couple of different fashions. One could be a manual input. And so what I thought I'd do is let's just create a couple data points here, just for the sake of discussion. So we're just going to key in the XYZ values and a radius. And I'll just put in a couple here. So let's do 0, 64. Key in the radius, and again, we're just kind of working our way through here. I've got about 6 of them, so it shouldn't take too long. But you kind of get the idea and see what the automation then does from a creation standpoint. But again, this is one of those things that, again, users, it's kind of simple, but it's just an area of SolidWorks that's often needs to be customized because the exact way of doing this isn't available. And so let's just do 2 more. and then we'll hit go. So again, just keying in the coordinates of my XYZ points to create a simple tube. In this case, this is just going to run a sweep along the, what it's going to do is it's going to create a 3D sketch and then run a sweep along there. And we give the user the ability to input some data. And it should be noted that really this can be customized specific to whatever your requirement might be. That's the great thing about the API. But I can come in and I can say, okay, is this solid tube or is it a hollow tube? And then, you know, key in a tube OD. So let's just say it's 2 and like a wall thickness, and then provide whatever the units are. And if we didn't want to enter in a variable radius for each of these line items, we could enter in just one and apply it to everything. But once the information's entered in, we have the ability just to go out and create tube, and that's what it does. It brings in the XYZ coordinates. It creates the three-dimensional sketch associated with it, and then just runs a sweep along it. And so as you kind of look at this, look at it from the right, we've got a little bit of a slope happening in the Y direction, and then a number of different bends happening as well.
Not a lot.
So that's the ability just for a user to key in some values. Some variations on this as you kind of start to think about this is, hey, we just want the point data brought in, right? We just want the ability to run a curve through these points. We don't necessarily need the geometry. You know, so there's lots of different variations on kind of this theme of, hey, I just want to grab some point data and allow my user to bring it in. We'll take a look at another example of this. Let's just run it one more time. And again, the nice thing about this is that not only can we do a manual input, but if you have Excel data, that could be brought in as well. So we can just say, you know what, import from Excel. This one's got quite a few more points, you know, so this is a little bit more complicated. But, you know, again, same kind of options. We'll just say that we've got a 375 OD and just give it a wall thickness and then hit create tube. So what you'll see is it creates quite a bit more complex sketch. It's going to go through each of the vertices, radius those out, and then run the sweep along that. Right. So now I've automated what could have been a more complex task for my end user. You know, creating that 3D sketch. Maybe it's for a heat exchanger or whatever it might be. Just allowing to input some information in and allow the automation of the geometry to happen from there. So again, just another nice case where an add-in, you know, becomes pretty nice. And really the reason this became an add-in was we have a third option where the user can actually pick a 3D sketch that they may have already created. Now again, this has been an add-in that's kind of migrated itself over the years, so some of it's not quite as pertinent, but the idea is that we've got lots of flexibility with being able to select, understand geometry in SolidWorks, and then manipulate and create automation from there. So those are two examples of add-ins and the value that the add-ins can start to create. They're really analogous to, you think of the Gold Partner program, right? Those are add-ins because we're leveraging the SolidWorks environment. We're allowing the user to make selections, and we can create automation to leverage that from there. The last example, the final example, is another really exciting one, and we were very pleased to get permission from BIMBA to kind of show this one. Again, BIMBA is another great customer of ours. And their requirements were interesting. They have a sales configurator that they currently use. It's attached to their ERP system, and they want to be able to input information in, and then have SolidWorks be the engine that then actually created information for the sales configurator. So if you can begin to imagine the idea of keying in some key information from sales, saying go, and what happens in this case is, again, just to kind of touch on some of the technology we're able to do here. So we're using what's called IIS, and the configurator will push an HTTP request to a server that it doesn't have a screen on it, it's just got solids loaded on it. It's pushing the request out to the server where there's a service, And the service is basically parsing the information from the configurator, and it's creating an XML document and putting it into a spool folder. Spool folder just being someplace where the information can sit. We then created also a listening service that basically just listens to that folder and says, hey, if there's a document there, if there's an XML document there, grab it and push it into SOLIDWORKS and begin to generate a model, create the drawing or update the drawing, and then just save it out as a PDF. Okay? And what's kind of nice about this is that not only were we doing this, but we were also communicating back with the database so that the database understood that, hey, the request had been received, information in the database table was updated so that we could provide feedback back to the end user. But that's kind of the idea of how this progressed. And so when you start to think about really kind of taking that next step of leveraging the API to create a piece of automation, this becomes a pretty neat example. And so we'll take a minute now. Realize that I'm kind of running this all on one machine, so that obviously doesn't completely show the methodology or how we did it, but to the point, the idea is being able we can actually show the automation here. So let me close this down. And I'm going to close SOLIDWORKS. And so what we'll do is we'll actually fire up this console. And this is just going to simulate the kicking off of the automation here. Okay, so let me bring up one other window just so you can kind of see some of the back end of what happens. So we're going to key off the request. And what you'll notice when I key off the request is that it fires up SOLIDWORKS, and it also puts a request. You can see the actual XML file that it creates. It was a little quick, but it actually creates that file, and SOLIDWORKS begins to fire up and manipulate the end models to create the automation. And so this was, again, a pretty neat example where we're basically just driving a design table to manipulate a component and then creating a drawing associated with it. And when it's done, SOLIDWORKS does a nice job of going out. It shuts itself down. It cleans up the folder where the request was made, and then basically doesn't save the model. It just purely is there for the creation of the PDF. Now, what's nice about this then is it pushes the PDF out into a directory that we had set up as a web-based. So if I just refresh my directory here, you can see that now the PDF is sitting there. I can click on that document. And again, you can think about the fact that we want to be able to maybe push this out to a sales configurator or to sales themselves, maybe emailing it to them, so that they can actually see it. So let me accidentally close that. Let me bring it back up here.
Not for the type of stuff that we do.
Right. So let's take a look at another one. We'll grab. Let me pull this out, and we'll just do another. Pull in another request. So this would simulate the pulling in of another piece of information from the sales configurator. So just drop it in there. So this part's obviously manual, but you imagine this happening quickly, automatically in a communication between a lights-out server and a database or an Oracle setup. So in this case, again, this would happen on a trigger. It would send the request. Again, it would fire up SOLIDWORKS. And what's kind of nice about this is that we can queue the items so that it's just basically sitting there generating drawings and generating PDFs related to the models, and going from there. So again, it's just another neat way that you can leverage kind of that third area of having an executable available to go out and grab SOLIDWORKS, fire it up, create some information, and then store the information in a location that an end user may then need to leverage. Again, and as we show when we refresh the web view of that folder, there's our new PDF that was just created. So again, just another nice opportunity to further leverage the automation capabilities, the API toolkit. the idea being that we can really make this quite extensive in the sense that we can start to involve enterprise PDM, obviously it being built on a database and having an API toolkit available. Even simulation has an API toolkit. So when you start looking at designs that not only do I want to automate, but they're always restrained and always loaded in the same location, it's just the loading may vary, and I need some validation, some type of reporting validation as part of my design requirement. So you start thinking about those kinds of things that are just purely requirements, but really could be leveraged through automation. The API toolkit becomes a great set of tools to begin to leverage at any level, whether it's a macro, an add-in, or an external program that's just calling SolidWorks and firing it up. So with that, Charlie, those are the core examples that I had planned to show today. I'm going to turn it back over to you and allow you to share. We'll share the slides again.
Okay. While we're doing that, we do have a couple of questions from our audience, Steve, and I'm going to read a couple of them to you, and you can try to answer them. First, from Don Owen, there was a question. Is the automated sketch fully defined with dimensions?
So the automation that we currently have is not. It doesn't fully define the sketch. However, that's easy enough to do. Again, that becomes a great point of when you can define exactly what you want to have happen, the tools are there to be able to make it occur the way you'd like. So great question, but yeah, it's definitely possible. Ours isn't set up. The example I showed wasn't set up that way.
Okay, another question, Steve, from Virgil Mockel. When editing configurations, what operations will generate an API event?
I'm trying to remember exactly what the event handlers would be in that case as it relates to configurations. I mean, more than likely it would be the rebuild, because every time you adjust a configuration, SolidWorks is doing a rebuild, and so you could probably couple it with the rebuild. A good resource just for everybody who is an API programmer is the API help. It's extensive and it describes all of the event handlers that happen for the different aspects of SolidWorks, and so that would be an easy one to kind of get a definitive on based on what you're specifically looking to do. So.
Okay. Another question from Rabi Hantour. How do you create an add-in?
The add-in is created as a DLL. So you basically it's done in whatever whatever programming flavor that you want, whether it's C#, C++, .NET, and then compiled together as a DLL, and then that's how the add-in is loaded. It can be registered either through an installer, or SolidWorks actually has the ability to do a file open, and one of the file types is a DLL, so you can kind of load the add-in on the fly. But that in and of itself is essentially the core of how add-ins are handled. They're
Okay, all set on that question, Robbie? And a question from Jay Tuttle. Which is the best language, VB, VBA, or C++? Or let me add another one, VB.NET.
There are subtle nuances to each of them. I don't know that there is a best or better. SolidWorks continues to support all of those and will in the future. And so it really boils down to a lot of what you know to begin with, and then there are just subtle nuances between how each language handles different situations. But to really say, oh, you should use this specific language, I don't think that's a statement that really needs to be made, because any of them that are supported are great languages to write in. It really kind of depends on what your background is in. So.
I think a lot of the current development, current macros and add-ins are being written in VB.NET. And so in today's environment, the VB.NET might be the best initial direction if you had that skill or resource available.
Yeah, and sometimes, and just to add
Go
to
ahead,
that,
Steve.
Charlie, sometimes the choice of a language can be really dependent upon the user base that you're deploying to. So, you know, if the .NET runtime environment is something that's consistent on all of your users and is very applicable and it makes sense based on how your user systems are set up, then sometimes that becomes the driving force for which language you end up choosing is going forward. But to be sure that the .NET is definitely a very popular language to create add-ins.
There's a follow-up question in the from Robbie, and that is, in the last example, did you use a Windows service to fire an event?
Yes. So there's a web service that was used. There isn't a Windows service. It's let me make sure I get this right. I talked to our programmer the other day about this. There's an executable that currently runs on the machine that's monitoring the spool folder. So that in and of itself is not a service that when the machine fires up, it automatically starts. It's an actual executable that has to be started and placed into listening mode. There is a service that runs within IIS to manage the incoming information from the configurator, but the actual executable that's listening to the spool folder is in fact an executable that's started up, and runs in that manner.